So let's review some of the things that we learned about how Prolog works. So let's start off, let's write a rule called flip3. It'll take two parameters. And if we have a list A, B, C, D, E, we want this rule to flip the first three elements. So it would return C, B, A, D, E. The rest of the elements stays the same. So to do this, we flip 3. We have three elements in the head, and I'll call them H1, H2, H3. And then we have the tail, which whatever's in the tail, that's fine. We're not concerned with the specifics there. That's going to unify with a list that has H3 as the first element, H2 as the second, and H1 as the third, and it has the same tail as the first list. So let's consult our file. And you'll see that that flips the first three elements. And this isn't just for letters. If we did numbers here, in fact, if we just did three elements, it would know enough to flip those. Now, if we gave it a list with two elements, it would be false. It wouldn't be able to unify that with anything because to flip 3, we have to have at least 3 elements. So we don't need to check, is it long enough? If it's not long enough, the rule will fail. Now that we've seen that, let's write another rule just to show that once we unify these variables, we can use them any way we want to generate all sorts of things. So we'll call this do strange thing, and it'll take a list with at least 4 elements. Again, if the tail is the empty list, then it's a 4-element list. And I'm going to unify that with a list that has A, D, D, C, B, A, B, C, D, and then the original tail. And I misspelled that, so let's fix that. So now, when I consult, let's take that list above and let's do the strange thing. And it looks like I didn't save it, the file name, but we'll just have it change the name for us, and you'll see that it does this weird arrangement that we set up. And again, that's because once these unify, I can put them in whatever order I want in the next parameter. Let's see more about how lists work. And one thing we could do is write a reverse myReverse method. And our base case for that is going to be the empty list. So let's see what it takes to do that. So here's our first attempt. So myReverse, if there's a head and a tail, we're going to put the tail in front of the head. We're going to reverse the tail. And that's going to give us T1. And that's the list that we put here as the head. So let's give that a try. And I guess I'm sort of giving away what might happen here by calling it attempt 1. So I'm going to call myReverse on A, B, C, D, E, F, G. And clearly that's not what I want. Now the order is correct. We have G, F, E, D, B, C, A. So it did reverse the parameter, the order, but notice this is the pair where we have this strange pair paired with A, this strange pair paired with B, and so on. So clearly this didn't work. So now for my next one, right, one of the things you may notice is A is in a list. If we make this a list now, so the good news is we have a list, but we have a list with just 2 elements in it, where the first list is this weird list. Okay, so let's try this. First, we want to make sure we comment out that previous attempt, because if we didn't, then that would still get resolved or unified before it got to this rule. So we want to make sure anything we don't want to use, we comment out. So we have my reverse HT, and we'll create a result in the body of our rule. So we're going to reverse T to get T1. And now we're going to append T1 with H to get the result. Okay, so let me line these comments up. So now let's consult, let's run our rule, and that's false. And the reason is because when I try to append T1 to H isn't a list. It's going to be one of these atoms in my list. So how do we make it a list? It's actually pretty straightforward. We want this to be a list with just one value, H. Okay, so we put brackets around it. Now it's a list. So we can consult, and now we can see that the list is reversed the way we expect. Okay, we talked earlier about how Prolog can do some pretty powerful searching for correct answers. So let's say we want to make change for $1. So we can have half dollars, quarters, dimes, nickels, and pennies. Okay, now half dollars, actually let's do nickels first. There's only 20 different values, or 21 different values of nickels we could have to get change for $1. We're going to have somewhere between 0 and 20 nickels. Now for dimes, we're going to have 1 to 10. For quarters, we're going to have 1 to 4. And for half dollars, we're going to have 0 to 2. Okay, so now as we calculate this up, if you remember back in algebra, you probably did a word problem similar to this. Anytime you have money, you're not counting up how many of each type of coin you have. You're adding up together how much value you have in those particular coins. So if you have 2 quarters, 3 dimes, 5 nickels, you have 2 times 25 plus 3 times 10, and so on, and you multiply those to get your total. Now we haven't brought in pennies yet. So first let's calculate how much we have without the pennies. So we multiply half dollars times 50 cents, add that to quarters times 25 cents, add that to dimes times 10 cents, and we add that to nickels times 5 cents. Now we want to make sure that the subtotal here is less than or equal to 100. And then once we do that, the number of pennies is 100 minus the subtotal. What this is saying is, try any of these values for the nickels, dimes, quarters, half dollars, any of these valid values. Then calculate how much money you have in those coins. It has to be less than 100. The number of pennies you have is 100 minus that subtotal, because pennies are 1 cent each, and so we don't have to multiply times 1. So let's save that. And we have a singleton variable. And so you'll notice here, we didn't capitalize our T. Anytime you see that, always make sure that you rectify it, because almost always it means something bad. And actually in this case, what we would have done is done this calculation, but then subtotal would just had to have been less than 100. It actually wouldn't have been able to unify that, because it wouldn't know what value to try. We still have a singleton, it looks like. We didn't save. So I can get change for $1. Let's say I have I want one of each type of coin. Okay, so there's no way to do that. But what if I have $1/2, 1/4, 1 dime, 3 nickels, and 5 pennies? That's also false. What if I have just 2 nickels and 5 pennies? That works. Well, what are my options for dimes and nickels if I want to have $1/2, 1/4, and 5 pennies? So I can have 2 dimes and no nickels. Whoops, I told it no, so let's continue. I can have 1 dime or 2 nickels. I can have 0 dimes and 5 nickels. So that's the different ways I can make change for $1, assuming I get back at least $1/2, 1/4, and 5 pennies. In fact, I can make all of these variables, and it'll give me all the ways to make change. So everything is 0, pennies is 100, or everything is 0, but I have $1/2 and 50 pennies. I have $2/2 and 0 of everything else, 1/4 and 25 pennies. Here we have $1/2, 1/4, 25 pennies, and so on. And you can see as I go through, it'll give me every possible way to make change for $1. Now I could add some additional capabilities here if I wanted to say, give a value here for how much change I wanted to give back. Instead of saying, hey, has to be $1, I could say, hey, I want this to add up to 47 cents, or I want this to add up to 83 cents. Something like that what I could do is add in another variable here and then use that variable in place of 100. Here I'm saying using 100 because $1 is 100 cents, but I could certainly have another parameter to make this rule a little more flexible.